Dear students, Sudhir Pandey again welcomes you. Now today we'll discuss another topic, that is the electrical capacitance. Electrical capacitance, in this chapter today we'll discuss the parallel capacitor, parallel plate capacitor, parallel plate capacitor. Okay, this is our first topic of today. It is the first topic. So parallel plate capacitor means when two plates are separated by a very small distance d, having equal and opposite charge plus q minus q. Okay, and suppose there are some dielectric materials filled between the plates of the capacitor. Okay, we know the surface charge density sigma is equal to q upon a, and also we know E is equal to, for the single plate near the plate, already we have derived, it is the E is equal to sigma upon 2k epsilon naught. Okay, we know this already, we have derived. Okay, now see, to find the resultant E between the plates, due to this positive charge, the E is always in this direction, away from the positive plate, and due to the negative plate it is towards the negative. So E plus E means the total E or the net E is equal to E plus E, that is the 2E. Clear? So it means 2E means 1 up, that is the sigma upon 2k epsilon naught plus sigma upon 2k epsilon naught, or we can write sigma upon k epsilon naught E. Is it clear? Okay, now if you have E, then easily we can find the V also. Okay, since V is equal to E into D, from where it comes from, E is equal to V upon D, that is the potential gradient. And here we can write sigma is equal to Q upon A. So write here Q upon A K epsilon naught. Okay, now this is the E. Put here E. So Q upon A K epsilon naught into D, it is equal to the V. Now once you have V, easily we can find the C also, capacitance of this parallel plate capacitor. C is equal to, you know very well, C is equal to Q upon V, or Q upon, put here V, Q upon QD upon A K epsilon naught, or it is equal to A K epsilon naught upon D. This is the capacitance. Okay, take it as a first equation. Now from this expression it is very much clear. That is the conclusion, you can say, conclusion of this expression. First conclusion is that C is directly proportional to, see the formula also, C is equal to A K epsilon naught upon D. So C is directly proportional to area of the plate, this area of the plate, and second, C is directly proportional to the dielectric constant of a dielectric material, and C is inversely proportional to 1 upon D. It is by increasing the D, C will decrease. That is, you can say, inversely proportional to the C. So this is the first conclusion. And second conclusion, if you take K is equal to 1, that is, put the air or the vacuum instead of any dielectric material, then this formula will reduce as C naught is equal to, C naught means the air capacitance, that is the A epsilon naught upon D. Okay, this is the second formula. Okay, it was the first equation, this is the second equation. Now if you divide 1 by 2 by 2, we have C upon C naught is equal to K, or simply we can say C is equal to K C naught. It means new capacitance will be the K times of the air capacitance, or the capacitance of the air capacitor. So this is the parallel plate capacitor. Okay, after this we can discuss the another important topic, that is the combination of the capacitor. Combination of capacitors, or you can say the capacitance, how we can add capacitors, combination of capacitors. So it is possible by two methods. First, series combination, and second is the parallel combination. Now come to the series combination. Okay, in series combination, all capacitor of the different capacitance. Suppose this is the first, this is the second, suppose this is the third. Three capacitors of different capacitance C1, C2 and C3 are connected one by one. Means suppose a positive charge is given to the first plate of the first capacitor. It will induce the negative charge in the inner part of the first capacitor. Now it will pass. It is the positive, negative, and finally it is the earthing. Okay, so Q charge is given. So Q charge will be unchanged. It is the constant. But you know Q is equal to CV. Or if we take the Q constant, in that case C inversely proportional to V. Okay, means both will depend mutually on each other. Okay. Now potential difference will change because the C is changed. So here potential difference between the plates of the first capacitor V1, between the plates of the second capacitor V2, and between the plates of the third capacitor, it is suppose V3. Okay, three different potentials, and from this formula it is very much clear the total V will equal to the V1 plus V2 plus V3. We can write like this. Okay, and V from here V क्या है? V is equal to Q upon C. So V1 we can write Q upon C1, V2 Q upon C2, and V3 means Q upon C3. If the net capacitance of all the capacitors is C, we can write V is equal to Q upon C also. Clear? Now Q upon C is equal to, take the Q common, 1 upon C1 plus 1 upon C2 plus 1 upon C3. Q is cancelled. So 1 upon C is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. So this is the resultant of the three capacitors when are connected in series. So now see what are the features, what are the properties of this series combination. First is that you can say the reciprocal of the resultant. C is the resultant. Okay, the reciprocal of the resultant capacitance or total capacitance is always equal to the sum of the reciprocals of the individual capacitances. Individual, that is the 1 upon C1 plus 1 upon C2 is equal to 1 upon C. This is the first. And the second thing is that the resultant is always less than the least value. C is less than the least value of capacitance in series. Okay, which is connected in series. Means suppose you have connected 1, 2, 3 capacitances, so resultant will be less than 1. Okay, less than the least value, you will find the resultant. Okay, this is the series combination. And third point you should know, Q always constant. Q always constant in series combination. Now come to the parallel. Okay, now come to the parallel combination. Parallel combination. In parallel combination, if all the plates, first plate of all the capacitors having the capacitances C1, C2, C3 like this, so all the first plates of all the capacitors are connected as a single point. Okay, and the second plates of all the capacitors are connected on the another point like this. It means if you give the charge Q, it will be distributed. Suppose it is the Q1, it is the Q2, and here it is the Q3 like this. Okay, total charge again it will come Q. Is it clear? Now how can we find the resultant? From the formula, as you know, Q is equal to CV. What is the constant here? Because all the capacitors are at the same potential. So V is constant here. V is constant. So what is variable here? C and Q. Because C is variable, so that's why the Q is also variable. It means the Q1 is equal to C1V, Q2 is equal to C2V, and similarly Q3 is equal to C3V. And from here you can see Q is equal to Q1 plus Q2 plus Q3. Is it clear? Q1 plus Q2 plus Q3. So put the values. It is the C1V, it is the C2V, it is C3V. Okay, and if you consider the resultant capacitance is C, in that case you can write Q is equal to CV. Okay, so now CV is equal to C1 plus C2 plus C3. Take the common V. V is cancelled. So the resultant we find here, C is equal to C1 plus C2 plus C3. So this is the resultant capacitance in the parallel combination of the three capacitors. You can take more than three also. In that case it will be the C plus C4 plus C5 plus C6 also. So now see what are the properties. First property is that the potential is always constant. And second, the resultant yani ki C is always more than the maximum value, more than the maximum capacitance, okay, which is connected in the parallel combination. And third is a definition, more than it means all the resultant capacitance is always equal to the sum of the individual capacitance. So this is the combination, parallel combination and the series combination. So in next video we'll discuss some more property of the capacitors, what are the dielectrics and what is the effect of the dielectrics when it is placed between the plates, and what is the electrical energy, etc. We'll discuss in the next video. Thanks all of you. And if you have not subscribed this my channel, please subscribe it immediately, so that when I upload my video you will get the notification immediately. Thanks all of you.